If you do that, you're going to get 22470. And if you want to put a dollar sign in, you could. I'm not going to bother because then that's going to take more space. Now, to get the second spot, it's going to be the term before it. So 22470. And we're going to times that by the ratio because it's that amount plus 7%. And you're going to get 24043, I believe. You're going to continue that pattern. So this number times 1.07, adding on the interest at the end of the year, you would get 25726 and 27527. So you can see that the amount in the bank at the end of each year is increasing and quite quickly. 7% is actually quite a steep interest rate. Generally, bank accounts have between like 1.7 to 3% being like quite high. So what we're finding is the common ratio, and then we're going to write an explicit equation for A, capital A, being the amount in the bank. Now, a common ratio I've kind of already spoiled because that is the amount that we're multiplying by each year, and that is 1, the amount, so the whole 1 plus 0.07 being 7% as a decimal. So our ratio is just going to be 1.07. Now, another way that you could find that if that didn't click for you is you could grab any term and divide it by the term before it. Remember that formula we did at the start? And if you did that, you are going to get our common ratio, 1.07. So there's another method as well. So we've got our R. We know our A was 21,000. And now we're going to write an equation for capital A, where that's just like our term. It's like our A of N, right, for any spot. And going to our reference sheet, we can cheat. We can go, okay, well, for any term, we know it's geometric, so we know we're looking at geometric sequence. When we are looking at this equation, it is going to be our A times our R and minus 1. Pop in these values that we've got, 21,000, 1.07. Again, I like to use brackets around my R, even if it's quite nice, and minus 1. Okay, so for any year, I can pop in that N value where year 1 was 1. So year 100 would be N is 100. And I could get how much money would be in that bank account at the end of that year. Okay, so I'm running out of breath and I have a cold, but we're almost there. So the average annual rate of inflation, so that means it's going to be going up. So if I get a decreasing answer, something's gone wrong. In Kazakhstan is 2.6%. So inflation rate means it's going up by 2.6% each year. Okay, so if bread cost, I'm going to highlight some of this just so we're good. Inflation, bread cost $3.65 in 2015. Part A is asking, okay, well, what would the bread cost 1 year later? So what we need to consider is going up. So I'm starting with 3.65 and I need to multiply that. Now it's going to be the same method that I used just a moment ago, where I said this is the same thing as 0.026. If you're confused as to how I got there as a decimal, percent means out of 100. If you want to get it as a decimal, you just grab this number and you divide it by 100, and that'll get rid of your percent symbol. Okay. Another way to think about it is that number out of 100 is written like this. So we are going to be multiplying, but again, if I multiply by just that 0.026, all I'm finding is 2.6% of, which is not what the question's asking. It's increasing by that, which means that my rate is going to be 1 plus the increase. So 1.026 is my rate, not percent, because we got rid of the percent. So I'm going to multiply by 1.026. Now, if I do so, I should get an answer of, I believe I've done this before, $3.74. Okay, so that's how much the bread would cost in 2016. Now, if I was to do 2018, I have a couple of options. I could multiply this by 1.026, get an answer, and then multiply that answer by 1.026 again. That's getting a little bit messy when if you have a look at C, I'm going to be writing a recursive rule, in other words, an explicit rule, the formula for Vn being the value of bread, n years after 2015. Okay, so we already found this was 1 year after. So I'm going to jump straight to C, and then I'm going to come back to B, all right? Because that's going to make it a little bit easier. Now we already know what R is because I found it just here. A is always our starting value. So that's going to be this 3.65. And if I have A and I have R, getting the formula is super easy because it's just going to be A times R. Probably forgotten something there. Let's double check real quick. No, looks good, looks good. Where n minus 1. And that's our recursive rule. The only thing I've done wrong there is I've done T instead of V, where we're using V to mean value, but it's still the term. So like you're not that wrong for using T. Okay, so that's C done. We just want to find the rule for n years. Let's go back now to B and pop in 2018. So you need to think, well, how many years after 2015 is 2018? Well, you go 1 year after is 2016, 2 years after is 2017, 3 years after is 2018. So what I'm actually finding is V3, the value after 3 years. So I'm just going to pop in my formula. Now, 3 take away 1 is 2. And we're done. We can just get our answer straight away. I do so believe that I have not written this down yet. So we'll quickly chuck it into our calculator. Yeah, 1.026 to the power of 2. And we should get 3.84222674, which we're going to round to $3.84. Dollars and cents, we're always going to round to 2 decimal spots. Okay, so hopefully through those examples, you can see how this could be really useful when you're doing any kind of inflation or money prediction problems. For example, teachers just recently had a big union discussion about teacher inflation. So like inflating salaries to keep up with annual inflation of the Australian dollar. Because if your business isn't inflating, your salary isn't inflating in alignment with the Australian dollar inflating, then your job can become relatively less valuable. Okay, so here are your tasks for this week. Depending on how we're going, I think we might actually try and cut down a little bit. We might do 1 task a week. We'll see how we go. You have a choice. Again, there's a maths-based task up called geometric sequences. You know the benefits, you know the pros and cons. The other version is maths in focus, pages 20 to 21, questions 6 through to 20. They're quite short, quick questions, and again, they're just on this page. So if you want to download this or do it on your computer screen, go for it. Hopefully that kind of makes a bit of sense. Remember, it's just like arithmetic, except we're multiplying, and you have your formula just here. If you have any questions, please get on to me as soon as you can, and have a really good week. Sweet. Thanks, guys.